and welcome to Geeks for Geeks. Today we would be solving the problem count pairs with the given sum. So let us just find out. So basically if I just give you the summary of this, you need to count the number of points A and B which sums up to the given target. Okay, fair enough. Like, what are the different points? Like, if you see 1, this is 1 and this 5 would sum up to the value 6. So that is one pair. Then 1 and this 5. This 5. Earlier, what was that? Earlier, these two 5. This time, it is these two 5 which would form the pair. The next one is -1 and 7, which would be the elements that would be forming the pair. Next, let's move forward to the second sample test case. The very first one would be this and this. The very next one would be this and this. The next one would be this and this. So this is how, after doing some combination, you would get 6 pairs. So what is the thinking process if you see up the very first problem? The very first idea would be that I would think of something brute force. Let's think of something brute. So what can be the scenario? You need to find pairs, and basically pairs are what? You need to find two elements A and B which are basically ARR of I and ARR of J. That sums up to the given value, that is the target. This is the thing. So I can see that I have two pointers I and j. Just by summarizing what is told and forming it an equation, I can have this. Because a and b are not from any other values, you don't need to generate it. It would be existing inside the array itself. So now what I can do is, just by this I can formulate a very simple brute force. What is that? I know that I can have one I which would be rotating on the whole array, and I would have one more j which would be finding the pair for I. So let's say we have the elements as 1, 2 and 3, and the target is 3. So what I can do is, I can stand on 3. I can consider a of I as 1, and then I would find the j of it. Okay, so now I have considered a of I. So values of j would be what? A of j, the probable candidates of j can be 2 and 3, and this is how I can find it. So what I can do is, I would simply write a for loop which would start from 0 and go till the point of n, and this would be for what? This would be for the value I. Then I would again have a nested loop which would go just after I, like when I would be standing like 1, 2, 3, 4, 5. Okay, why just after I? That 2 is also concerning. So I would stand at this index and I would count 1, 2, 3, 4 and 5. Okay, so 1 and 3, let's say the target element is 4 itself. Okay, so I would stand at 1 and then I would find 4. But if I stand at 4 and if I start from the beginning, not after 4, then I would count 1 and 4 again. That is why I would have the jth loop as I plus 1 till the value of n, and that would be the value for j. And as for each I, we are trying iterating on all the elements of j. So I can say that to check one I would be doing big O of n operation. Now to check ni, that would be multiplying n on both sides, that would be big O of n square. And the space complexity, we are only using variables, and variables don't count to big O of space complexity. That is why at this point the space complexity would be constant and the time complexity would be big O of n square. Simple enough? Okay, so now you told this to your interviewer, and now the interviewer expects you to optimize this. Okay, fair enough. Let's refine it more and let us think. So we are given what? A sorted array. We are given a sorted array. We need to find ARRI and ARRJ, which would sum up to the given target value. This is what I need to do. So how to solve up this problem? How to optimize this? The very first idea I can think of is, like, very naive idea I can think of is, I can have a of I equal to target minus a of j. So if I stand on this element, I can search this value. If I stand on this element, I can search the next value. So searching the next value, what I can do is I can simply use something known as binary search. So that would be again n log n. No, Siddharth, we still need to do better. What can be a better idea to this? The very first I thought of, see, this is a sorted array and finding element. So I thought of binary search. Then what are the other algorithms that I can apply in case of a sorted array? So in case of a sorted array, if the elements remain the same, that the elements are static, the next algorithm I can think of is something of two pointers. Okay. So like it is not the like simple way like I try to think of in this scenario, and then I narrow it down to two pointers. It is not that much intuitive, I would say, if you are a person who is a beginner to two pointers. So you should just see all the observation. Array is sorted, finding an element. So what are the algorithms that we can apply? Two pointers. Now try to think, can I use that tool to solve this problem? Can I use this tool to solve up this problem? Seems like good enough. How? So let's take an example at this point. So what I can do is, let's say the target element is 5, and currently we are at the extreme most point. I just want to land at 5. At this point, the only concern is to land at a pair which sums to 5. And this is a sorted array. So 1 plus 5, which is equal to 6. So what I can do? So if I move this pointer this side, the sum would increase. If I move this pointer to this side, the sum would decrease. So let's see. Now I come here. Now 1 plus 4 is equals to 5. Okay, Siddharth. Now I can see that I can simply locate pointers at the extremes. Why locate pointers at extremes? Because the general idea of two pointers is that we start from the very extremes. Why is that? Because locating at a particular place is not that much feasible. We have two pointers to consider. So just have it at the extremes, and then you should decide where I can land on. So I can simply have I and j at extremes. Okay, I and j at extremes. And then I can simply say that if ARR of I plus ARR of j, if that thing is greater than the sum, what I just did, I just narrowed it down. That is what? J minus minus. So I can simply say that is J minus minus. Okay, so we found a pair. Okay, we found a pair. Now there is one small problem. What is that problem? Now I can see that this 1 and 4 also makes a pair. This and this also makes a pair. So it's not that I can just ignore 4 and I and j and I can move forward. So if I just ignore this one, if I ignore this 4 and move forward, if I ignore this one, that's completely fine. But if I ignore this one, 4, and how would I decide which one to ignore? It might be a scenario that here there are two 4s. So still an issue. What we can do? So what we can do is, now when we reached a conclusion that yes, I and j is equal to the sum, what we can do is, we can simply iterate forward and count the values. Like we know that a of I plus a of j is equals to sum. Then what we can do is, I can say that the count of a of I consecutively is 2, and the count of a of j consecutively is just 1. So the number of pairs that would be generated is C1 multiplied by C2. Siddharth, how did you come to the conclusion? That's a basic mathematics. Still, I would show you. If there are A, B, C, and if there is D, E, F, the number of if you are allowed to choose every time one character from this team and one character from this team, it would be 9 teams. That is A, D, A, E, A, F, then B, D, B, E, and B, F. Same goes for C, D, C, E, and C, F. Same. So the idea is to, we know that we need to select one element from this team and one element from this team. That is why we would just count the number of C1 and C2 and we can simply mix up 1 and 1, and this is how we can say that. Okay, good enough. Now let's say we move forward to 2 and this value is 3. Now we again land at this position. So now we can again say that the number of values of 2 multiplied by number of values of 3 that is present. Now, there is one more scenario. What is that scenario, Siddharth? Let's say you have the value 4. You have the value 4 and you have 1, 2, 3, 4. So I would just write out the condition. So if the value is less, we would increment it. If the value becomes equal, we would just decrease it. You are now understand. Now I would have 2 pointers again at the extreme left and extreme right. But here, if you observe, as the values are same, I would just mark the indices also 0, 1, 2, 3. Okay. So now if you observe, this is a problem here. I and j, the target element is 4 and I and j both are pointing to the sum. So now what I can do is I can simply count out the value of 2 on this side. But this is a problem here. And at that point also this would count something. And even if we count half of it, that would be 2 multiplied by 2. So the value would be 4. So this is what number of ways to choose 2 items from K. So I can say that this is nothing but n choose K. So the value of n choose K is what? N factorial divided by n minus K factorial divided by K factorial. Let's just refine it more. Here we have the value as n factorial. So the lower value would be, the K value would always be 2 because we can always select 2 pairs. These two will also act as pair. These two would also act as pair. These two would also act as pairs. These two would also act as pair. So what we can do, number of ways to choose this. So what we can do is, this would seem something like this, n minus 2 and then multiplied by 2. 2 factorial is 2 only. Then I can refine it more. That is, I can simply say that n minus 2 factorial multiplied by n minus 1 multiplied by n. And this would be n minus 2 factorial multiplied by 2. I can say that. So now this would be there, n into n minus 1 divided by 2 when a of I is equal to a of j and a of I plus a of j is equal to the given value k. Okay, so when we have this condition, we would use this formula. When we have a value more, we would move this side. When we have a value less, we would increment the value and move this side. When we have a value equal, we would count out the values C1 and C2. And if they are unequal, we would do C1 multiplied by C2. If they are equal, we would do what? N into n minus 1 divided by 2. Make sense? Let's see the code. So we have the result initiated to 0. Then we have the length of the array. And then we have to the extreme 2 points. Then left plus right. If it is less, then we would move this side. That is, the sum would get increased. Left plus right. We move this side to increase the sum. We move that side to decrease the sum. When the sum is equal, that comes the point of contact. Okay. So we have a count 1 and count 2. We initialize both of them. First, we keep moving forward until we receive the same element. Okay, until and unless we were receiving 1, we kept moving forward till the point we reached here and the count was 2. So the count was 2 and here the count would be 1 for that 2, 2 and then for there. Now, if the elements are equal, then it would be count multiplied by count minus 1 divided by 2. This formula, n into n minus 1 divided by 2. Then, if it is not the scenario, if the elements are different, that would be count 1 multiplied by count 2. So by doing this, we can get the overall count of the number of pairs which sums up to this value. What is the time complexity? This seems like inside a while loop. We again have two while loops. So this seems like a n square, but this is not true. Why? I would tell you the intuition behind it. So I and j, they are at the extremes, and when they are moving forward, then they are never coming back. So like I can say that even if they meet at the between, I can say all the points before this were visited once by I, and all the points after this was visited just once by j. Okay, so it's like they both are on this side and they would eventually meet. They at no point you would see that left is minus minus and j is plus plus. That is, left minus minus is never. See, left here also, left plus plus. Wherever left is only moving forward, and right is only moving this side. Right is pushing that side. So now I can say that this is the way we can count the pairs. So that is why we can say that the time complexity is big of n, and we are only using variables. We are not using any auxiliary data structure. So the space complexity is constant. So now let us see if this code is working or not. Let us see this. Hope this works. This is working fine for the sample test case. And yes, we got an AC. That's it for today. Thank you and have a nice day.